Hello from the Forcetronics YouTube channel, and welcome to how to configure the ESP32 for light and deep sleep modes. And this is part 2 in a 2-part series. Before I get started, I'll just mention please support Forcetronics on Patreon, where you can find some really great exclusive content from various videos, including this video series. If you haven't already, please subscribe to the Forcetronics YouTube channel, and if you like what you see here, please hit the thumbs up. All right, let's get started. Okay, in part 1, we went over the different sleep modes that the ESP32 supports. What are some of its wake-up sources for sleep modes, and what are some of the nuances of using it? We also looked at the power consumption. We set up a basic circuit that allowed us to measure real low-level current so we could verify the current draw and essentially the power consumption when the ESP32 is in light and deep sleep modes. And in part 2, we're going to dive into the code on how to configure the ESP32 for light and deep sleep modes and for some different wake-up sources and how we can use, an internet connection in between sleep modes and things like that. So we'll do that in part 2. I'm going to start off by quickly looking at the API so you can find out where I got a lot of my information, as well as if you want to change some of the functions or understand how they work or implement different functions, you can see the functions they have available on the API. And then we'll look at the code in detail. We'll walk through the code. And while we're reviewing the code, we'll look at a couple demos of the code using deep sleep and light sleep. Okay, here is the web page for the sleep mode API for the ESP32 S3 version. And, in my videos, a lot of times, if you've seen other videos, I always say you got to read the data sheet. Well, this is almost like the data sheet for the sleep mode, right? It's the API description, and it gives an overview of the different sleep modes. It talks about, what turns on, what is off during these sleep modes. It talks about how do you handle Wi-Fi and Bluetooth, namely you got to disable them when you go to sleep. It talks in detail about the different wake-up sources, which I went over in part 1. And then, the important part is way at the bottom where it goes into detail on some of the functions that you can use. So if I don't cover every function you might want to use, for instance, I'm not going to cover how to use the touchpad to wake up. So this would be the function you would use to set up a touch wake up, right? And some of them will have an argument, this one doesn't, and then a lot of them will return these custom enumeration error codes that the ESP32 uses. And you can see for this one, it'll show you either everything's okay, ESP okay, or it'll show you the different error codes that could be returned telling you that you're not using it correctly or something's not set up correctly. And we do check error codes in the example sketch, as you'll see. But anyway, I wanted to make you aware of this so you understand where I'm getting the different functions. And if you want to build on what I have, you can by using this API. And I'll provide a link for this in the video description. Before we jump into the code, though, I just want to remind you of the setup. So I'm using the same design from part 1 that allows you to measure the low-level current. Here, though, I'll just be showing the code for going to sleep and waking up, and we'll be using the serial monitor to track the different wake-ups and the sleep modes that we're going to use in the code, right? So I just wanted to remind you that this is what we're using, the same design from part 1. And by the way, the schematic, the PCB design files, and the BOM for this design can all be found on Patreon if you want to access that. Okay, let's dive into the code. And while we go through this code, like I mentioned, we'll look at a couple demos as we go through this. So before I get started, though, I do want to recognize I did leverage some code from a Arduino example timer wake up, and you can see the author of that sketch here. And then I wanted to have some wireless connection code in here so you can kind of see how it can work with sleep modes. And I leveraged some simple code that that connects to Wi-Fi, grabs NTP time and date, if you're familiar with NTP time and date, from the internet, prints it out, and then, shuts off the Wi-Fi, right? Because one of my ways I want to use this, and this is why I wanted to include some wireless functionality, is I wanted to use this for sort of a cloud application where my ESP32 is in a remote location. It's monitoring some sensors. So what it does is most of the time it's going to be asleep, and then it'll wake up every so often, take some sensor readings, connect to the internet, send the data to the cloud, maybe collect some state information if it has to turn something on or turn something off, then go back to sleep for however many seconds, and then wake up and repeat. And that way I can have a cloud-connected, internet-connected device that's using very low power. So the only include files I'm using are for the Wi-Fi connection and the ability to grab time and date from the internet. I then use these constants to define how I want the code to work. So this first one, deep sleep, true. So if that's true, if that constant variable is true, that means the code will operate and use deep sleep mode and not light sleep mode. If I turn it to false, it'll use light sleep. Timer wake up. If that's true, like it is now, the ESP32 will wake up on a timed basis and then perform some function and go back to sleep and just keep repeating that. If you set that to false, it's going to use an external logic source as a wake up source. And then if you want to use the Wi-Fi capability where it connects to the internet and gets the NTP time and date, set this to true. If you don't want to use it, set it to false. These next two constants are for the timer wake up. So it's based off of microseconds. So this is just a multiplier. And then this variable 5 means it'll be 5 seconds. So I have it configured to sleep for 5 seconds. So the current settings, which we'll look at a demo at soon, is that deep sleep, we're going to use deep sleep, we're going to use a timer wake up, and we're going to use Wi-Fi and get the time before going back to sleep. Here's some variables that are used for the internet portion. So I just put in dummy names, but you got to put your network name if you want to use the Wi-Fi and the password. And then this is the web address for the NTP server that we'll talk to. These are some variables that allow you to configure the time and date based off of GMT time. And once again, I leveraged this from the Last Minute Engineers website, which was a great website. These next variables, I use these first two in deep sleep. So if you remember in part one, deep sleep is very low current consumption, which is great. But deep sleep, when you wake up from deep sleep, it's almost like performing a reset on your microcontroller because it's going to start the program right from the start. And it also, you lose a lot of your states and variables when you wake up. And so I'm sort of demonstrating that here. So variables, global variables that are stored in standard memory will not be maintained when you wake up from deep sleep, or I should say when you go to deep sleep, because all of that memory is shut off. If you want to save a global variable and have it maintained when you go to sleep in deep sleep, you got to save it in RTC memory. And that's what this tag is telling us, right? And this is from the API. So I'm designating this second boot count variable that says RTC at the end to be used in RTC memory. And so the idea is, since a deep sleep wake up is almost like a reset, these variables are meant to let us track how many times we've slept and woke up. Now, one of these won't work because it's not going to be maintained, and that's what I'm going to try to show here. The next variable is the error code variable to hold error codes from the ESP32. So a lot of these functions will return either ESP OK or an error code, which is good for troubleshooting purposes or knowing if you have something wrong in your code. So that's what that global variable is for. So in my first demo, like I said, we're going to use a timer wake up, deep sleep. We'll connect to the internet, get the time, and go back to deep sleep. And we'll be able to see how these RTC variables are maintained, but the standard memory variables are not. And then I'll go into this setup code. So let's look at a demo in action. Okay, I essentially restarted the code running, and we can see, so we started the S3 sleep mode example sketch. We are in deep sleep mode. Our boot count, so we have our standard memory boot count is 1. Our RTC memory boot count is 1. This next one is printing out our wake up source. Well, we didn't wake up. We had a power reset. So that's why it's showing 0, because basically it's saying there was no wake up source. We weren't asleep. So then we connect to the Wi-Fi network. We're connected. We then get the date and time, right? So this came from the internet. This is printing out an error check after a function call, so there were no errors. Then we say we're using a timer wake up. And so we're going to wake up every 5 seconds. We're going into deep sleep. When we awake, the setup function will execute again like a reset. And notice right after this line, we can see that we do a sort of a reset right here, right? Because this is what's printed out whenever you start the ESP32. And so it repeats, starting ESP32 S3 sleep mode example. But notice the boot number for the RTC memory was updated to 2, where the other one in standard memory was just 1. And now it says we have a wake up caused by a timer. So it recognized that we weren't just reset. This was a deep sleep wake up, and here's the cause. And if I scroll down, we can see, because this is executing every 5 seconds, right? So we can see this is the third boot up from the RTC memory because that global variable is being maintained. We can see the time and date data and so on and so forth. Number 4, number 5. So that's an example of deep sleep using a timer and doing an internet connection. And that timer, that same timer can be used for light sleep as well. But I just demonstrated it here with deep sleep, but you can also configure this code to work with it with light sleep. Now let's look up let's look at the setup function here. So we start our serial communication, we delay. I always like to do that to give you time to get the serial monitor running and viewed. I then just print out a start message. So this if statement is only true if that deep sleep constant is true. Otherwise, it won't execute. So since it is true in our setup, we're going to print out that we're in deep sleep mode, and here's our boot count. We increment both our variables. We already know that one of them will continually get reset when we go to sleep, but the RTC one that's in RTC memory will be maintained. This is the function we use to print out the wake up reason, right? So remember, every time we wake up from deep sleep, we start at this setup function again, and this executes, right? So that's why we're seeing that increment and the wake up reason print out each time. Now, if we have the Wi-Fi constant set to true, this is where we configure and set up the Wi-Fi and get the time and then shut the Wi-Fi off, right? So we're printing out these messages, we're beginning, we're trying to connect, we're then configuring it for what type of time we want to get, and then we're going to print out that time from the internet, and then we're going to disconnect and shut the Wi-Fi off. And remember, the API basically tells you have to shut off the Wi-Fi before going to sleep. You can't maintain the Wi-Fi or Bluetooth connections while in light or deep sleep modes. This if else statement is basically executed based on whether we're doing a timer wake up or an external logic wake up. So we did a timer wake up, so this was true. This function comes from the API, right? So it's an ESP sleep enabled timer wake up, and then it's setting the time, right? So it's using the 5 seconds times the microsecond multiplier to basically get 5 seconds. We get the return value from that function and we print it out just to make sure no error occurred. And then we let you know that we're going to sleep every blah, blah, blah seconds. If we don't want to do a timer wake up and we want to do an external IO wake up, which we'll show next in light sleep, this else statement executes, right? And here we can do that wake up whether in deep or light sleep. But the difference here is in deep sleep, you can't do a GPIO pin wake up. You have to do a RTC IO external logic signal wake up. I mentioned this in part 1. The ESP32 or the folks at Expressif, they use this RTC term to encompass a lot of functionality that I'm not used to. Usually an RTC just means real-time clock, but they use it to encompass basically everything that runs when you're in deep sleep. So the RTC memory, they have memory labeled RTC, they have IO pins labeled RTC. So just keep in mind, if you're used to that specific definition of RTC, when Expressif uses it, they're using it to define this whole low power subsystem they use in deep sleep. So just keep that in mind. So the only way to wake up from an external pin in deep sleep is using an RTC pin. And I showed in part 1, not all pins are RTC, most of them are. Pin 15 is one of them, so I'm configuring this for an external wake up 0. So you can only do 2 different external wake ups in deep sleep, external 0 and external 1. So I'm using 0, pin 15, and when pin 15 goes low, that's our wake up source. And then we print out to make sure there's not an error. This else statement is if we're in light sleep mode. Now, in light sleep mode, you could use the same RTC wake up pin, but I wanted to show that you can also use a GPIO pin in light sleep mode, but you can't use it in deep sleep mode. So that's why I have light sleep mode configured using a standard GPIO pin. I'm going to configure pin 38 to be a pull-up. The RTC IO, you can't configure that to be a pull-up. I had to use a resistor for that, so I'll configure that to be an internal pull-up. And then I'll set it as a wake up source, a low level, logic low as the wake up source, right? Then if we're in deep sleep, this is the last set of code we execute, and then we reset. Deep sleep, the way I have it configured, we never get into the main loop. So going into deep sleep, we have to flush the serial monitor. Once again, something that's mentioned in the API, they say make sure you flush the serial buffer before you go to sleep. Here's where deep sleep starts. And so when we wake up, we'll execute the same code in the setup function. We never get into the loop the way I have this configured. Only light sleep gets into the loop. So with that said, let's configure this to do a light sleep demo. And we'll use an external logic wake up and not a timer wake up. So if you remember the picture I just showed, there's a little toggle button. That little button will pull the external wake up pin low to trigger a wake up from sleep. So first thing I'm going to do is I'm going to scroll up to here and change my constant definition so that I'm using light sleep. And we want to use an external wake up. So we're going to set this to false. And then I don't want to use Wi-Fi here, mainly because I don't have the network configured. So I'm going to set this to false. So we're going to do light sleep, no Wi-Fi connection, and we'll do an external logic wake up. So I'm going to upload that to the ESP32. Okay, here we are in light sleep mode. You can see the starting message, and then it says in light sleep mode and using GPIO external logic signal to wake up. It's doing a couple error printouts because all those functions where we're configuring the pin, they return, their error status, which was no error. Then we're going to say we're going to light sleep. When we wake, the application will continue in the main loop, right? Because that's different behavior than deep sleep. So we're going to maintain our global variables when we're using light sleep. We don't lose that information, and we pick up in the code right where we left off when we wake up. So I'm going to push the button to trigger a wake up. There's the wake up. We're saying we just woke up from light sleep. If we were in deep sleep, we would not see this message. Wake up caused by external or standard GPIO pin logic. And then we're going back to sleep. I'll push the button again to wake up. And there we go. So this is asynchronous wake ups. We'll sleep as long as we need to until we get that external signal. So let's look at the code behind this. Okay, here I'm at the main loop because we looked at everything in the setup code already. And so first thing I do in the main loop is I turn Wi-Fi off. Now I mentioned that I probably shouldn't need to do that. It should already be off, but I'm doing it just in case. Then if this is not a timer wake up, this is where I enable the GPIO wake up. Right? So we configured the pin, we configured it for logic low, but we never said enable that wake up source. So we're enabling it here with this function from the API. Of course, we're printing out if there are any errors, and we only want to do this if we're not in the timer wake up mode. So that's why we have this if statement here. Here's where we say we're going into light sleep. We do the flush, because once again, that's what the documentation tells us to do, clear out the serial buffer. Then we do a light sleep start, and we grab if there's any errors. Here we're asleep. So this is where we basically are stopped, where we're sleeping, right? And so when I press the button, this if statement executes, right? And so this says if we're not in timer wake up, and this actually prints out any errors if we had any errors from when we went to light sleep. But then we're disabling the wake up source. So I just wanted to show this function action. I probably actually don't need to put it in there, but we're shutting off the wake up source if you don't want to use it anymore. If you can see commented out, I have the same function call, but this time it's for the timer wake up. So these enumerations define which wake up source you're disabling. And once again, I got this all from the API. Then we print out if there was any errors from disabling the wake up source. We print the wake up reason. I just delay for a second because if we're not using Wi-Fi, you'll just go right to sleep within a split second. So I just kind of delay for a second, which is a time you could be doing something, making sensor readings or whatever while you're awake, and then we go back to sleep. Now in the main loop, if we're using light sleep with the Wi-Fi, this if statement would be true, and this is just a carbon copy of what you saw in the setup code. But once again, we weren't using Wi-Fi in this example, so we didn't see that get executed. This is where we're printing out our wake up reasons. And I mainly leverage this from the Arduino example sketch, but they're using a switch statement with the wake up reason variable that they're getting from this function that's a part of the API, and it'll print out the wake up reason out here. Now, I'm not using all of these, but I just left these in here to be complete. And then this is the function that's meant to print out the error codes. Now I'm just printing out error codes that were common for the sleep functions. There's a lot more error codes for different, APIs in ESP32. So this is not an exhaustive list. It's just a quick one I made. And then here's where we're printing the local time if we're using that time.h library with the Wi-Fi to get the NTP time. This TM structure is part of that library. This get local time is part of that library. If we're not able to get it, we print out an error message. If we are, this is where we'll print out the time and date. And then, of course, we were shutting off the Wi-Fi and going to sleep from there. So that's an overview of the code. And like I mentioned before, this will be available for download on Patreon. All right, that's it for part 1 and 2. I decided to leave you with a picture of our current measurement circuit from part 1 if you're interested in checking that out. And of course, all the files for that are on Patreon, as well as the code from this video. If you have any questions from this video, please use the comment section below. And if you think I missed anything, please add that to the comment section below. And thank you for watching.